A short circuit happens when the positive side of the power supply comes in contact with the negative side. Now this creates an easier path for electricity to flow from the positive side to the negative side without having to go through the rest of the circuit. That's why the LED turns off. Now the problem with this circuit is too much electricity is allowed to flow through this jumper wire. We now encounter the same problem we faced previously when we were wiring up that LED. When too much current is allowed to flow, we risk damaging the components in the circuit. So we need a way to resist the flow of electricity. But we already have a resistor here, so we just take the output of that and plug it straight into ground. This is effectively a controlled short circuit. Now we can do what we did in the last video and use a button. We can use this button to control the short circuit. And as a consequence, we have something interesting that happens here. Now pressing the button turns the LED off and not on. See how this circuit is the opposite of the first button circuit we built. Since they're opposites, we say they're inverted circuits. So let's call this circuit the NOT circuit, because when the button is pressed, the LED is not on. And when the button is not pressed, the LED is on. So we call this the inverted circuit. Now we can actually build inverted circuits for all of the circuits I showed you in the last video. So this is an inverted circuit for the button circuit. If we use two switches back to back like we did for the AND circuit, now this circuit is the inverted AND circuit, or the NOT AND circuit, which is shortened to NAND circuit. So now I've wired up an AND gate to control the short circuit. If one of the buttons is pressed, the LED stays on. If the other button is pressed, the LED stays on. If both of the buttons are pressed, then the LED turns off. Now remember, this is the opposite of the AND gate. With that gate, we had to press both of the switches to turn the LED on, and it was off otherwise. Here we have to press them both to turn the LED off, but it's on otherwise. So like we did in the OR circuit, we connect both of the inputs of the switches together and both of the outputs of the switches together, and then the output is connected to ground. So if one of the switches is pressed, it completes the circuit to ground, which shorts the circuit effectively. And if the other switch is pressed, it does the same thing. If switch A or switch B are pressed, then the LED turns off. Now this circuit is called the inverted OR circuit, or the NOT OR circuit. It's usually shortened down to just NOR circuit.